Okay, we're going to turn the meeting over to Bob Primak. Bob, it's your show.
Okay, let me start a screen share. Now, is everybody seeing a document?
Yes.
Okay, what I want to start out with is just to let you know that in addition to Windows, there are other operating systems, one of which is Linux. In fact, Linux is older than Windows. It's older than DOS. It's been around since the earliest days of Unix. Well, not the earliest days, but it was derived from the old Unix operating system. I think what a lot of you are interested in is, why would I want to try another operating system other than Windows? Well, Windows 10 can be slow on older hardware. So you may have an old laptop hanging around that isn't quite up to modern standards, but has at least 2 to 4 gigabytes of RAM and enough storage space so that you can both install and run an operating system, things of that nature. Number 2 is maybe you don't like the Windows 10 user interface. That's what happened to me and pushed me to try to find a more traditional desktop, one that I knew that I could control how it operates and that would do things the way I like to work, not necessarily the way the latest Windows update makes things work. The Windows 10 download is huge. That's less of an issue now than it used to be with older computers. Linux is free, and I do want to emphasize there's 2 different meanings of free. Free as in you don't pay for it, and you don't ever have to pay for it, so it's not just a free sample or anything like that. And most of the software is like that. And also, Linux has this idea of freedom as in people contribute their code to a community, and you use this software freely. You can look into the code. You can suggest improvements. You can improve it yourself and submit what you improve. And the main thing is, you're not really asking people to pay you for your work in coding, in producing the software. You make your money other ways, perhaps by hosting services, perhaps by offering some kind of help desk or enterprise support, which many companies do. Linux has more free applications. You can get free software for Windows, sometimes the same titles, like OpenOffice or LibreOffice, many people have heard of. That's both Windows and Linux. And it began with Linux. There is some free software in Linux that you won't find in Windows. For example, there's a photo editing program called Photox, F-O-T-O-X-X, which does not exist in Windows. They're not going to make a Windows version of it because it's optimized for Linux, and in particular Ubuntu Linux, which is one of the more popular distributions. Right now, you don't need to worry about what a distribution is. It has been said that Linux has better security. Here's the perspective. By design, Unix limits the privileges of users. You can't run as administrator as easily. You don't run what is known as a root session. In Windows, that would be an administrator session. You just don't do that. And as a result, the security of Linux is better. It used to be said that Linux is more obscure, only occupying 3% of desktop users or less, and therefore it wasn't as big a target for malicious software, malware. This is no longer true, and it never was true of Linux on servers. If you want to know where Linux is, look at Amazon, look at Google in the cloud, look at Microsoft Azure, and look at anything else. Even Apple iCloud is running a variety of Linux. All of these servers that make the internet work are usually Linux servers. And that means there's a very large target area. And that means more and more malware is being targeted to Linux. Where you get these terrible breaches and security issues in Linux is that the servers usually have not been updated. And that's a big thing about Linux. People think it's so secure and so stable. They like the way it works, just like some people like their Windows software to be the version that you are used to. So you can find things in the toolbars at the top, and you can find how to make a bold or an italic, and you don't have to worry about the newfangled ribbon or some kind of a web app. Who knows what new interfaces they'll come up with next. You do have some control over that in most Linux programs, but you would have to configure them. But anyway, things are kept up to date. And that's one of the keys to Linux security. There are also some technical ways of keeping Linux secure, which would include security policies, which are beyond the scope of what I'm going to talk about. Linux performance, especially on less capable hardware, where you have like maybe as little as a Pentium processor, or you have limited amounts of RAM, or you have even limited storage. Linux will usually perform faster, smoother, with less demand on the hardware. Privacy, I'm not going to speak much to because you can have privacy in any operating system. It's just by design, most Linux distros do not send as much information back to somebody's home server, somebody's corporate server, or things of that nature. There is part of the philosophy of a free and open community is that we don't spy on each other. I don't know why I'm getting a message that people can now see my application. You should be able to. Anyway, there's also the reliability, which is what I alluded to with stability. People keep Linux running without shutting it down for days and weeks and even years. And you can't really do that very well with Windows, partly because the updates have to reboot. They have to restart the machine. In Linux, yes, you do have some updates that have to restart the machine. I won't yet get into kernel updates versus software updates versus anything else, because I would have to explain to you the various layers of an operating system. I will get into that a little bit in order to let you know the varieties of ways you can use Linux and devices you can use it on. And again, variety. Support that you have to go out and seek with Linux. You can get, say, Red Hat or SUSE, which do include support, and you pay for them. And those are enterprise packages. But if you have Ubuntu or Fedora or Mint, among the other popular distributions, you will have to look for your own support. And there are many online forums that exist. Some of them tend to be more technical. Others will support questions that come from newcomers. So I'm including references with my document, and there are references at the end of the document, so you can explore some of these things further. And number 13, I just don't like not having control over the appearance and the behaviors of my operating system and my applications from the moment that I boot up the machine to the point where I shut it down, and at all points in between. I can look into any of the code, I can change any configuration file, and if I make a mess of it, I'd better have a backup. In Windows, you also want to have a backup if you're going to experiment a lot, even if you're not. Okay, so I do also want to go over a few of the popular ideas of how you might try Linux and why you probably don't want to do some of them. Windows Subsystem for Linux, version 2, from an article. The most important thing to understand about the Windows subsystem for Linux is that it isn't based on virtual machines or containers. Basically, you're not running one operating system inside of another. When you download a supported Linux distro from the Microsoft Store, and I don't like calling them Linux distros, they are Microsoft Store apps, which emulate Linux distros. It doesn't mean that a virtual machine is created. WSL provides a layer for mapping the Windows kernel system calls to Linux and vice versa. This allows Linux binaries, which are programs, to run in Windows unmodified. So the code is unmodified, but Windows is acting as an intermediary between Linux and your hardware. I'll get to the structure of operating systems a little later, and you may be able to see why this is different from running Linux natively. So you do run into some you do run into some limitations, and you do have your applications will not run the same way as they would if Linux were running natively, if it were running as an installed operating system, or if it were running as a virtual machine. So if you're a developer who needs to compile Linux binaries, then the Windows subsystem for Linux is for you. While it's possible to run Linux GUI applications now using an X server, which is it's a compositor, and I'm not going to get into what a compositor is. It's just part of your graphics. WSL is not intended for the average user who wants to spin up, try out your favorite Linux apps. And it's not designed to show you what it's going to be like to run Ubuntu or to run Fedora or to run any of the other popular distributions. So developers are trying to figure out, are they going to be able to run their applications on Linux, in Windows, and in various other ways in the cloud, for example, in the browser? So I have a couple of references if you want to look more into that. There's also a popular notion that Chromebooks can run Linux through something called Crostini. Crostini is the code name Google uses for the Linux application support for Chrome operating system. On Chrome OS, Linux applications run in a certain type of container that runs in a virtual machine. The virtual machine isolates Linux processes and applications from Chrome OS, and the Chrome OS security and stability remain. And there's more on what Crostini is in a reference here, and how to set it up on a Chromebook. Only certain Chromebooks have Crostini, not all of them. They have to be recent, and they're usually pretty expensive. So is a virtual machine a truly independent operating system? In a word, no. The physical machine is called the host. That's the machine you're running your main operating system on. The many virtual machines that you want to run, say you put a virtual machine inside of Windows, it's called a guest. The end user experience is, which is emulated within the virtual machine, is nearly identical to a real-time operating system experience running on a physical machine, with one important exception. The virtual machine guest operating system is sharing resources with the host operating system. The host operating system is mediating all hardware interactions. Drivers that are present in Linux may not carry through into a virtual machine under Windows, because Windows may not be able to drive that hardware that way. And there's code that doesn't work properly either, especially if you're having to do anything with Linux root privileges or administrator types of privileges. So there's more on what a virtual machine is from Red Hat. So the virtual machine is emulating the guest operating system, not running it natively. You probably should have a lot of resources in any computer that will run Linux in a virtual machine, even though Linux itself doesn't use a lot of resources. Windows plus Linux does use a lot of resources. So the bottom line is, if you want to get a feel for Linux and how to unleash its true power, yeah, you could start with using a virtual machine, or you could start by making a USB flash drive that runs Linux as a live operating system. Again, it's not like running Linux natively. You're running in RAM, which is slower, and it has limitations as to what operations you can do. Okay, I am going to try to share now a diagram to get you a little more up to speed on what an operating system is like. Let's see if we are sharing. Is everyone seeing architecture of Linux?
Yep.
Okay. All computer operating systems have to address hardware, and that'd be all kinds of things like internal and external hardware, interfaces, things of that sort. And the direct interface is called the kernel. The kernel in Linux, when it directly addresses hardware, will use its own drivers. But if you're using a virtual machine in Windows, you're using the Windows kernel to address the hardware. There is a shell layer, which is intermediate between your applications and utilities and the kernel. It communicates. The shell layer is also where your desktop environment is formed. And that gives your desktop its appearance. I want to take just a brief moment, if I can, and maybe you will be able to see my desktop. Am I sharing my desktop now?
Yes,
Yep.
Okay. I have modified things quite substantially from right off the download, but this is one of the Ubuntu desktop environments. This is modified from Gnome, which is a very popular one. And it is not running on the latest graphics compositor, which is Wayland. This is running on Xorg, which is the older one. So I have a launcher down here. I have a top panel, which is a GNOME feature, not a strict Ubuntu feature. Ubuntu had an older desktop environment called Unity. Unity did not have a top panel. I use what is known as a shell extension. You can put extensions into your shell in GNOME the same way you can put extensions into a browser and make it look different and make it be able to do different things. So I've got all these tasks on my taskbar. That is a shell extension. The icons on my desktop wouldn't be here were it not for a shell extension. I can see my workspaces. Linux uses workspaces, which I am switching between, and you may not even be noticing. But I don't think I can, within the same share, switch my workspace suddenly. But when I'm changing shares, as often as not, I'm actually changing the workspace I'm working in. And this is absolutely seamless in Linux. Windows is still working on it. They're pretty good in Windows 10 with workspaces. With virtual desktop is another thing it's called. But Linux does it better because Linux has been doing it for longer. And most distributions or distros are able to do that sort of thing. There's a lot of interesting stuff. There's a desktop background, and you can change your wallpaper. And the applications come stringing down here. If I hit this button, I get an all apps screen. And if I'm lucky, I'll be able to share a screenshot of that. And here is, do you see my apps?
yes,
Okay. You know how Windows has their alternate desktop, which shows the Windows Store apps and everything like that? Well, these are the actual installed applications, which I have available in my Ubuntu. And I can switch between seeing these or seeing my, whoops, I'll get into a new share. And I do notice there's something in chat. But anyway, there. But anyway, I can go between that and the other desktop. Just to complete this, why don't we do that other desktop, and you should be able to see that we have returned to the desktop. Okay, so anyway, there are those two different versions of the applications, the favorites and the full screen, which shows all the applications. Okay, now let me get back to my document. All right, I think what I'm going to do at this point is probably skip a lot of what I'm going to say about the shell, except to say your applications layer is also important in security. Because if an application can, I'm going to go back to the diagram of the layers. If an application can reach down into the kernel, it has total control of the operating system. That's called running as root in Linux. And you don't want applications to do that any more than you want to be running as root in your current user session. So you run as limited users, applications have limitations. And if you want an application to run with extra permissions, if you want it to run temporarily as root, you have commands such as sudo. And I'm just briefly going to see if I can get the command line up and running. I don't expect anybody to become an expert in command line from what I am going to show. Let me see if we can share the command line terminal. This is a command line terminal, and you can type things into the command line terminal. And one of the commands is sudo, and let me just choose. See, it'll ask me for a password. And that's something that the user account controls will do in Windows. And I'm going to do this. Oops. I got it wrong. Misspelled. That's one of the problems with command line. You have to type. And is everyone seeing now that a file explorer type of window has opened up?
Yes.
Okay. This now has the ability to modify system files. Normally, if I run this file explorer called Nautilus, I would not be able to modify and maybe not be able to see some of the system files in these kinds of directories like this one. And this is another one where, as an ordinary user, I would be able to see it, but I would not be able to modify files. This is a file that would not be modifiable. We've got configuration files. Okay, all kinds of stuff. So I have to wait a little while for that to end in the command line. There's one other trick you can use. It's called a security policy. And in Ubuntu, it's a policy kit. So I can do policy kit exec. And I'm going to do this as BleachBit is a cleanup program, not too unlike CCleaner, but it does Linux stuff. And with a little, see now it people may not be able to see this, but there's a popover that looks like a Windows UAC, and it's demanding my password. You may not be able to see it.
We can see it.
I can see it.
Good. If I got my password right, now we will see BleachBit. And this is an application which, if I check off a bunch of things, I can clean up a lot of logs and temporary files. And the Chromium cache would also work for the Chrome browser. So my browser caches, cookies, storage, all kinds of interesting stuff. No time to go over all that tonight. So I'm going to close this application and I'm going to start a share. Before I do that, I'm going to look. Okay. All right. That's something I don't need to reply to. Wait a minute. What happened here? I want to get. I'll do a share screen on my desktop. That'll get rid of everything. Okay. Now, let's see if I can get back to the document. Now, I'm pretty sure I'm not putting everybody to sleep just yet, but the Linux operating system in my document, I've got much fuller descriptions of what is a shell, what is a kernel, what is the hardware layer, what is the application layer. The other thing the application layer allows you to do is to reach out to the internet, and it allows people to reach in from the internet. That's one place where you will need to harden Linux. Web browsers are just as vulnerable in Linux as they are in Windows, and they need special security just like they do in Windows. Be careful where you go, and be careful what code you download. Linux software, let me get out of this, which I'm not going to cover. Okay, I should probably go over what Linux software you will find just right out of the install. And I'm going to try doing a different desktop here. Okay, let's try this. Now, some of the more commonly used software that comes with Linux. Linux carries a lot of its own software, and it also has, for each distribution, its own software center or repository. So you can get all your software from one place. And I do want to show how I can, I could show that, but right now I'm going to show how I can get software. There is a software center, which is called Gnome Software. It's looking more and more in Ubuntu like the Windows App Store. And it's very heavily focused on something called snaps. I also see I have some things that want to update themselves, but I'm not going to do that right now because I'd have to leave the meeting. But I have some installed applications. I have installed some of these, including BleachBit Cleanup. I have actually installed something that used to come with Ubuntu called Cheese, which allows you to test your webcam. Various other things I have put in here. But there are things I didn't add. Firefox web browser is one of them. And this is what Firefox does. It just opens as a web browser. The original Mozilla Firefox was developed for open source, and it was developed for Linux before it was developed for Windows. So GNOME shell extensions, I'll talk a little bit about them later. I think it does come with Ubuntu, or at least most people will download the GNU image manipulation program, the GIMP. I actually find that pretty clunky. It's not my favorite image editor. It takes a learning curve just the way the Adobe Creative Suite takes a learning curve. And the main thing about it is it's open source. You can run it on Windows, but it's made for Linux and it runs well on Linux. Google Chrome is something I added. It's not included by default. The Chrome or Chromium, which is the open source version, the Chromium browser, you download and you install. But here's something. It's an office suite called LibreOffice, which is available for Windows as well. And there are lots of different things it contains: a word processor, a spreadsheet, and a slideshow program. The slideshow program is not fully compatible with what you find in Microsoft Office or the Microsoft presentation programs. There are 2 or 3 different Windows presentation programs in use these days. But anyway, this LibreOffice presentation program, I can find out what it is, but anyway, it produces perfectly decent slides, and I have been known to do presentations based on them. This is the graphics editing part of it called Draw. And the presentation one is Impress. The spreadsheet is Calc. The word processor is Writer. And Writer saves documents not in the Microsoft Office doc or docx format. It saves them in ODT, which is an open document format. And there are several open document formats, but more and more, Microsoft Office is being forced to accept these open source formats and to be able to import and use them. There are some formatting issues, but if you don't use advanced formatting, it's hardly noticeable. And a lot of people have the ability, therefore, to use documents that are put out in the native format of LibreOffice. Draw is the vector graphics program. Again, not necessarily my favorite drawing program. And there's a database program, which you don't have to install with LibreOffice. And what other software? I have things for handling PDF files. There are some sound handling and streaming handling applications. There is a screen recorder, which works sometimes, sometimes doesn't. Good old Thunderbird, which is available for Windows, is a good desktop email client. And it works in Linux, it works in Windows, and you can exchange files and email folders and various kinds of things like that. I won't get into transcoding, but there are some good transcoding programs that are Linux specific. And VLC Player, I'm sure people know what that is, but VLC Player also works quite well in Linux. In fact, it was designed to work in Linux. And it also works in Windows. And there's a lot of things we can do. Several people have presented about all the things you can do with VLC Player in Windows, and most of that is also applicable to Linux, although there may be slightly different ways of making it work. And we, of course, have things like Zoom, which is just beginning to be supported. I am not able to share my screen for application windows using the standard Ubuntu desktop environment, which uses the Wayland graphics compositor. Instead, I have to use the X compositor. So I'm using that in order to do this presentation. And little utilities. Evince is a document viewer for PDF and other formats. And that's the one that comes with. Files used to be called Nautilus, and it is what I showed you, the file system navigator. And we have all kinds of GNOME specific stuff. I can also take screenshots, and there are a few limitations on that, but I can do it. And we have a software updater, which will handle the updating of software, and you can set up which repositories it will use. And so you can get all your software in one place and update it all at once. In Windows, you generally are not able to do that. And you have all kinds of problems finding out what's out of date, what can I update, and where can I get it? Well, you can get it all in one place. The software updater uses the Ubuntu repositories, and I'm going to launch the updater and just show you how it runs, if it will do it. And there it is. It's just checking for updates now. And I think it's going to show me I have some. And I'm not going to do them because I would end the meeting right now. It takes a little while to finish, and then, nope, up to date. There's some things that can be upgraded that were noted before. All right. See, in the Software Center, it says there are these things that can be updated. I suspect they are things that can be upgraded. These are very system level sorts of things. I'll do that later when the meeting is over. So I'm going to end the Software Center, and I'm going to go into another package manager that basically is operating out of the same repository, which is called Synaptic. And I'll log in. Note that we are running in this is just a little reminder thing that I can dismiss. We are running now as root. I can do any changes I want to my system this way, and that's not necessarily a good thing. I can also mark some upgrades, and no, Synaptic doesn't seem to think I have any. So whatever that Software Center is doing, I would have to do separately. But this over here refers to some markings. And those markings show up as green shaded boxes here in this interface, in the Synaptic Package Manager. And you can mark upgrades. You can take things that are not installed. Let's go with not installed, and they will have empty boxes. And you can check them off and mark them for installation. And you can mark a whole bunch of different things for installation. The Synaptic Package Manager has an advantage. There are things called dependencies in Linux. You can't install a program and get it working without these dependencies. Synaptic Package Manager, unlike the Software Center and unlike installing from a download, will tell you if there are conflicts. It will tell you if something is missing and you need to add it. And it will allow you to check off what needs to be added and mark it for installation. It won't always do that, but it very often will. Sometimes you just have a package that you can't satisfy the dependencies. The other thing you can do is you can save your markings, and then later you can read the markings back from a file. That means all your software, or at least a large amount of it, can be restored just by reading a file and just clicking apply, sit back and have a cup of coffee. You're back to where you needed to be, and you have the latest version of everything that you have. Well, maybe not everything, because there are a couple or three other ways of installing software. I just want to make mention of them, although probably I will not be covering a whole lot of it. Let me get my document back and see whether I can. Yes, I will get back to how you install the operating system, Linux itself. But what I want to say right now is the reason you mark all your software and save to a file is because sometimes things go wrong and you end up having to reinstall Linux. Some people have to do that with Windows if they experiment a lot. And it's good to have a backup of your software and of your user data. Your user data in Linux, almost all of it lives in, and I am going to share this. It lives in your home directory. Most, if not all, of your user data and your user settings are in here. You can back it up with compression because it can get big if you have email files, for example. Or you can store it just without compression so that you can just copy and paste. And then you need a lot of disk space in order to store the backup. But between your home directory and your software markings, you've got about 90%, maybe 99% of anything you may need to restore if you have to do a fresh reinstall. And once in a while, it's probably a good idea to do a fresh reinstall and get rid of all the old junk that stays behind. So that's one way of backing up. You'll notice that I may have to stop the share in order to do this. Okay, let me get back onto my desktop. There we are. And now I should be able to close that up. Okay, so you can change some configuration files in order to change the appearance of Linux or to change how some of your software works. And those configuration files may be system files, and they may be outside of your home directory. Those are files I would save separately. I'm not going to get into what grub is and how to customize it because that is getting into some technical detail. But it's in my document, a little bit about it. And there are extra repos, extra software sources. First of all, you have the Synaptic Package Manager, which I just showed. But there are also some app stores that are able to get you out of this problem with dependencies. Because sometimes you want to have a piece of software. You can't get it in the normal repositories, but it is available out there. And it can be packaged in such a way that it carries all its dependencies with it. You could use an app store like Snap, which is what Ubuntu likes to use. And there's another method of doing it that's another curated selection of software, mostly used in Fedora and other RPM distros. They install differently from Ubuntu. That's all you need to know. And it's called Flatpak. Both of those will work either on Debian or RPM, both different kinds of distros, both different kinds of installers, and they both work using systemd, which is a way of automating some stuff in the Linux kernel. I think it's kernel level. I may be wrong. But anyway, there also are things called app images. Those are the most similar to Windows portable apps. And they can be integrated into the desktop in Linux, just the same way you might have a portable app integrator. For example, some people run the NearSoft utilities, NearSoft. And there's an interface you can download, which will allow you to launch each utility individually and to keep track of the utilities and update them and make sure they're all up to date. Well, there's an integrator like that for app images in Linux, at least in some Linux distros. I'm not going to go over the various interfaces for the Fedora updater, but just to say, just as there's Synaptic for Ubuntu, for Fedora and its group, its family of Linux, there is something called Dragora, which is a graphical interface for using DNF, which is dandified yum. Yum is the actual installer in Fedora, whereas apt or Synaptic is the installer in Ubuntu. So different Linux distros have different installers. You can also customize how your boot manager, which is called Grub, how that looks. The boot manager is the first thing you see when your computer turns on. You'll see a splash screen, and then you'll see a menu that lists different things you can boot into. And if you get it set up correctly, Grub will show you Windows. It will show you several different kernel versions of Ubuntu. or whatever your Linux is. And it may show other Linux installations if you're doing more than one Linux installation on your computer. It's possible to run many, many Linux distributions with one home directory, although you turn that home directory into a partition in order to do that. That's technical, so I won't go into details about how that works. Just know that one home directory can serve many installations of Linux on the same drive, on the same hard drive or SSD. And it takes up much less space than doing full installs, each with their own home directory. Because as I alluded, the home directory usually takes up the bulk of the space. The Linux system is very small. It has a small footprint in most distributions. Okay, I've alluded to things about backup strategy. Why am I not talking about image backup or cloning? It's because in Linux, with all the ability to reinstall your software with just a single import and then a single click, the ability to just get your software really fast. You don't have a registry to worry about. You don't have product license keys in most cases. You don't have these complications, which make it so difficult to reconstruct Windows. In Linux, you don't have to worry about that. So we don't usually use something like Macrium Reflect in Linux, although you can. You can use something called Clonezilla, which makes a clone. And just to make a small distinction, an image can be restored to a partition different from the partition from which it was created. A clone is usually restricted to just that one physical drive, and you can restore only to a partition that has the same partition number and various other technicalities. So clones are more limited than images. That's the take home, that's the takeaway lesson. And there are more complex file systems than the one used in Ubuntu, the one I'm using in Ubuntu. So the only reason I do a clone is just in case I need to get back to where I was before I started messing with the operating system. And otherwise, I would probably reinstall and just import my markings and get my software back, and maybe put my configuration files back in and have my settings back. Okay, and I do have in my document some special use cases and some current issues affecting Linux. Okay, and I've talked a little bit about how I have my desktop organized and what it looks like. So what I am going to do is go back, if I have a bookmark for it. I want to get back to installing Linux, and I think it's just before this section. And then we will get on to discussion time. I did configuration, tailoring. Here we go. Installing Linux. It is suggested to first make a USB flash drive, which you can boot on most PCs, and try out your Linux distro, or try several, before installing anything on the hard drive or the SSD. I have references listed as to how to make such a Linux live drive on Windows, at least until something changes in Windows, which hasn't changed yet. How to make one of these on a Mac OS computer, or how to make it on a PC that already has Linux installed, either Ubuntu or a different Linux. The procedure is very similar for Fedora to make a live drive. You won't get the entire Linux experience, but you can get a little bit of a feel for whether or not Linux will work on your hardware. And that's the important thing you need to do. Why go to the trouble of installing or even creating a dual boot if you don't know whether it's even going to work? So that's the main use for Linux Live. Also, in high security environments, you might want to run live so that you leave no traces. There's a form of Linux called Tails that is used for that. Okay, so the process of installing Linux depends on whether or not you want to keep Windows on the PC or not. The simplest install is to allow the Linux installer to treat the whole disk as available for your Linux installation. This is the default for most distros, including Ubuntu. The partitioning and formatting will be handled by the installer, but you can also go through a process of making your own partitions and doing other things using gparted, which also comes as a live USB or CD. Or you can use your favorite Windows-based disk utility. Dual booting itself is beyond the scope of this talk, but I do have references about how to set that up and references about how to get some Chromebooks, and indeed most Chromebooks, to be able to run Linux in an actual dual boot, not as a child root, not as a container, not as part of Chrome OS, but as an actual Linux installation on a Chromebook. It is not a project for the faint of heart because you can brick the Chromebook. Once installed, Linux can be configured, and you have settings available just as you would in Windows, except the settings don't send you to all sorts of different screens, although there are several different kinds of settings depending on what you want to change. And there are configuration files, and there are shell extensions. I think that's about as far as I want to go this evening, so that anybody who's still awake can ask some questions, make some comments, and contribute. And at this point, I think I will stop sharing. We can go back into our group mode. How's everybody doing?
Good.
Fine.
Great.
So questions, comments?
I have a question.
Yes.
What kind of file systems does Linux use? In other words, NFT, whatever it is that we've got.
Okay. Linux natively will usually use an ext file system, ext2, ext4, something like that. Although more and more they're using something called zettabyte file system, ZFS. And there's one called ButterFS, BTRFS, which is used now in Fedora by default. These are file systems which Linux desktop does not natively communicate with, and it can't read them. It can't detect them. It can't fix a disk that has them on it. You can use the old FAT32, FAT16 file systems, but then you lose things called journaling, indexing, stuff like that. Windows can have a utility put in that will read ext file systems. Windows servers do use ZFS sometimes, and they can communicate with ButterFS. Fedora servers, Ubuntu servers can handle NTFS. My Linux installation is a dual boot, and I do share NTFS partitions because I have a utility put into Linux that allows mounting and using NTFS file systems. So the bottom line is Linux can read Windows and alter Windows, but Windows has a much harder time reading Linux and cannot usually alter Linux system files.
So I could plug in a USB that's been formatted in Windows and it would be able to read it in Linux.
Oh yes, USB drives in Windows are either NTFS or more commonly FAT or exFAT. exFAT, you need a utility in Linux, but it'll work usually. I've read SD cards that were made in Windows. I've got a partition I share that's NTFS, and Windows uses it for data, and Linux uses it for data. I have used Linux in my dual boot to modify Windows and solve a couple of Windows problems that way. Linux does not respect Windows permissions. So you can do things that even an administrator can't do in Windows. But with great power comes great responsibility. Don't misuse that power because you can wreck Windows. And it's a lot more expensive to put Windows back than to put Linux back. Anyone else?
But when if you recall, I did a presentation when we were back live on using Linux, and I found it real easy to use. I used Ubuntu. Found it very, very similar to working with a desktop and setting a desktop up as you do in Windows.
Yeah.
But I gave that PC away, and I haven't played with it since. But I wasn't intimidated by it.
Back then, Bill, you were probably using Unity with the X server.
I don't know.
Nowadays, the default for Ubuntu is GNOME with Wayland. And that is a real pain and a bother. And here's why. Wayland is still under development. One day, Wayland combined with something called Pipewire will allow screen sharing like we're doing tonight, and it will allow all kinds of wonderful things. But it's one of these things like nuclear fusion power. It's always 5 years over the horizon or 5 months away. We'll get it in the next upgrade or the next one or the next one. It's not a high priority. So it's changed.
Not surprised.
But you can go back and use Unity, although now it's called Lomiri.
I still have the USB drive, but I haven't played with it.
There is also a new distro, a fork called Ubuntu Unity. And that's the one you're going to want. Or most Windows users will be happier with Mint and Cinnamon as their desktop. Cinnamon is related to KDE. And that's much more Windows-like. More Windows-like than what I started with. My desktop now is my own.
And what about all the various different drivers for like running Wi-Fi and running a disk drive, running a CD drive, reader, that sort of stuff?
Right. A lot of drivers are present in the Linux kernel. And it is possible to get additional drivers, but in some cases, your hardware, in order to drive your hardware or your peripherals, you would actually have to recompile the kernel. You would have to compile a special kernel. Sometimes this is done for you. For example, for Chromebook, you need all kinds of different things that are unique to Chromebook. And there is an Ubuntu that has been modified for that. It's called Gallium Os. And Gallium Os does have the keyboard correct for a Chromebook. And it does have other modifications. And it may support, although I'm not sure it supports, internal audio on some Chromebooks. But that's a really out there in left field kind of application. And I would say 99% of people aren't going to be interested in it.
I've got a 10-year-old laptop that's actually, it's got the latest Windows on it.
Okay.
But it's slower than molasses. Could I run Linux on a USB on that?
Why don't you try it? Just make a USB of Mint or Ubuntu or whichever you want, and just figure out how to get it to boot into the USB. You will be running in RAM, which of course is going to make it slow, but you'll know whether or not it supports the hardware.
Okay.
Wayne,
You'll have a good idea anyway.
That's what I did, and it was an old PC when I did it.
Okay.
It was probably about the same vintage.
I agree with running it first off of the USB drive.
Yeah.
However, I will say I've got a lot of machines I'm running Linux on, very fine, that are up to 15 years old. I'm even experimenting right now with one that is circa 2001. And when you get far enough back, you cannot boot up off a USB drive. You have to use the old CD if your Linux is small enough, or you have to use a DVD. And a lot of those old machines did not know what a DVD drive even was. So it becomes a big issue. But I've been playing quite a bit with some antiques just to see what I can do.
Yeah, and Tim, you might have noticed when I was presenting, I have Bracero, which is for burning CDs. And I have an external CD reader writer, which I can plug into my pretty much up-to-date Skylake generation Intel Nuke, which doesn't have an internal optical drive. So I could burn a CD or a DVD for another computer, and then we could run it live, see what happens.
Well, I will tell you on this one machine, it's an HP Pavilion Nancy 5415 model. And I guarantee you're not going to do any of that stuff. I even got a couple that are older than that. And whether I can do anything with them or not, I don't know. But one of them is a 486 laptop. There's no USB ports and there's no optical drives. So the only thing you got is a floppy drive, and that's it.
You might find a very old distro of Linux that can do that.
Bob, we're gonna call it quits now and go on
Okay.
to the rest of our program.